is with 0. And after that, we are going to write this formula that will eventually keep on changing, going for this loop and keep on changing weights and biases. Okay. And eventually, how many times we are going to repeat it is equals to number of iterations. How many times we are running a for loop. Usually it's in thousands of time because I'm taking all the rows at a time and then doing the average and then doing the calculation. And once I'm done, I will get the final weights. And these weights are not something which are zero. These are the weights that will look something like this. And we are going to have 10 such weights. Okay. So right now, if it is mentioned in this particular way, it will not be exactly in this way. It will be something else. Okay. And we have written the algorithm in the last class as well that was giving you the exact weights and biases. Okay. So this is the whole process that we have discussed in the last class. Okay. And as I've told you, this is just linear regression algorithm. In the exact same way, we have a lot of other algorithms as well. Okay. Now, what is the agenda of today's class? Okay. If you guys have any question in this so far, do let me know. Share yesterday's doc. Yes, I'm going to share with you. A regression will predict this. Yes. Okay. So I think so far, no doubt. Okay. But in between, if someone have any doubt, do let me know that as well. We are going to have a discussion on that. Okay. Now, this is day 3 where we are going to run this machine learning algorithms and we are going to deploy them basically. Okay. But before deploying them, let's go back and let me run all these cells and show you what exactly we have discussed in the last class. So we have loaded the model, right? And we have shown you the data as well. This is just to show you, right? So that after that, I've taken a screenshot. That's it. And then I'm splitting the data in train and test. Why I am splitting the data in train and test? Anyone? What's the use of splitting the data in training and test? So to split the data in training test, yeah, do let me know. At the meantime, let me go ahead. So I was taking this x's, these zeros. We were having the m's, and after that, these are the formulas that we have already shown you. This is first of all what I'm going to do. After that, I'm going to compute the gradient, and after that, this is where I'm going for a for loop to train my model. And after training the model for a couple of iteration, this is the loss that has to be decreased, right? And these are the weights. So after training the model, these are going to be my weights. So I can go back just to make it exactly how it should be. These are going to be the final weights. Okay. Now these are so many weights. So usually we need to so these are going to be the actual weights. Some of them are negative, some of them are positive, but in general, this is what we have. Okay. And not only that, we also have a bias as well. So we need to add that part as well. How can we miss it, right? So, and the bias, the calculated bias that we have after doing all these things is this is the bias. And let's go back. And this is the bias that we have. So initially we started with random weights, which are all the value 0. And after going for all these iteration, these are the final weights that I had. Okay. And this is something we have calculated based on linear regression. Okay. Training data. Okay. So now I got a couple of answers. Why we need training data? Training data is to train the algorithm and test data to test uh, if my algorithm is working correct or not. Yes, that's the correct part. To check the model works well or not, output the label yes. To check the accuracy of to find the accuracy of the data. Yeah, that is correct. Okay. So basically why we have test data, because it's same like why we need test data, because I need to have some unseen data. Based on that only I can check the accuracy of the model, right? Imagine if I'm using the same example. If I'm giving you 100 questions and in to train yourself, and the same 100 question, out of those 100 question, I'm giving you 20 of the question in class test and 20 of the question in final exam. That's something that cannot define you you're intelligent or not in that exam specifically, in that subject specifically. We need to have some unseen data, right? Based on that only you can see if you are intelligent enough or not. So this is why we have test data. So on test data, we usually check the accuracy of the model. Okay. Does not memorize the data. Exactly, Sophie. That's correct. Okay. Now let's back to the model. This is something that we have discussed as well. After that, I have saved these things. This is nothing but a model. There's nothing but a model only, right? Now, what I'm going to do, I'm doing the exact same thing here. So here, whatever thing that I have done here is a simplified version of that has to be done, because here I've added too much documentations and everything. Okay, but if just talking about the coding part, the same thing can be done in pretty easily if I'm using inbuilt libraries, right? And once my model is done, trained, I can check, I will usually check the accuracy of the model, that how well my model is performing on test data. Okay, and for checking the accuracy on text data, this is what we usually does. Okay, I'll take the test data, I'll give my current weights and biases, and I will get the prediction based on the model. So this is the prediction that I have got on test data. This is the prediction I have for test data, and these are the actual labels. These are the actual labels, these are predicted labels. So by executing this, I will find the average. Now you might be thinking, sir, why I'm finding the average? So if I go back, tell me one thing. If your task is where to find the data set. Okay. So to find the data set, I am executing this load diabetes. I'm loading the data set directly from Skiller. Okay. Now the funda is pretty simple. Okay. Like confusion metrics, not exactly like confusion metrics. Confusion metrics and these things are something that we usually use for classification based problems, right? But before that, let's discuss about what exactly is going to happen now. Whenever I am training a model, okay, and if I'm training a model that is very much specific to prediction categorically. For example, if your task is to predict the stock price will go up or not, if your stock price will go up or not, that's a binary problem, right? So if you are giving me 100 questions or 100 stocks, and you are going to ask me if the price will go up or not, so out of 100 times, how many times I am predicting correctly would be my accuracy. So out of 100 of them, I will say the price will go up or down. This is the basic answer I'm going to give you. Binary answer, yes or no. So this is a classification based problem, and you can easily calculate the accuracy of this as well. That how many times I have predicted correctly as compared to the total number of predictions. This is very simple, right? The issue will arise if it is a regression based problem. Because if it's a regression based problem, you are going to ask me what is going to be the stock price for tomorrow. Now, if I'm saying stock will go up, it's not going to work this time. I need to give you the exact prediction. For example, if today the stock price is 100 rupees, tomorrow the stock price will be, uh, my prediction is 101. This is my prediction. Okay. And in actual, the prediction is means in actual, the stock price have become 101.1. Now, though I'm correct, but how much correct I am? Because even if the prediction is 101, my prediction is 101 and actual price is 101.01 even, that's not the exact value. So it's not working category wise. That 101 means 101.01 will become 101 only. So to overcome this, we usually don't go for accuracy. We go for mean square. We go for basically the error based on the actual price and based on the predicted price. What is the difference? The difference should be minimum. Lesser the difference, better my model is. So for classification based problem, we usually take accuracy, but for regression based algorithms, we take errors. Okay, we have root mean square error, we have mean square error, we have R2 score, we have a lot of different ways through which we can predict it. Okay, through which we can evaluate how well my model is performing. Confusion matrix is one way how we can do the exact same thing, but that's for a classification based problem. This is a regression based one. Okay, what's the name of the project? Okay, the name of the project is predicting the diabetes of the person. So diabetic prediction or something like that. You can name it anyhow. Okay, now this is what it is. If anyone is having any doubt on this, do let me know. The funda is pretty simple. In classification, I know the number of outputs, right? Stock price will go up or not. So it's easy to calculate the accuracy. But you cannot easily get the accuracy on regression based problem, because if stock is predicting, if stock price is probably 101 and my prediction is 101.01, though that should be correct, but it is not correct, right? So in these particular cases, I'll find the error, the actual error and the predicted error. Okay, and this is exactly I am doing here. Okay, I've taken the actual predictions minus the actual values, the prediction and the actual values, taking their average, subtraction, and then finding the mean. So this is the error that we have. This is how far my model is on an average to the output. Okay, and after executing it, here you can see residual errors. If I'm doing the basic error differences, so you can see on an average there is a 60 unit difference, 61 unit difference. Means uh, if my model is predicting 100, if the actual value is 100, my model can predict up to 40 on an average, or 160. This is the basic difference that we are getting, because this is how far my model is and this is an average value. The lesser the value it is, the more accurate your model is. Okay, let's take a very simple example. For example, I hope you might have used uh, digital, what I would say, blood sugar meter. Okay. So in digital blood sugar meter that some of you might have in your homes as well. Uh, Inside that there is a basic strip that we have. On that strip, like, you can have a needle, and after that you just need to put some drops of blood on that meter, and based on that it will calculate, okay, this is blood, these are your blood sugar levels. Okay, this is something that can be easily done. Okay, but if you are going to an actual chemist shop, and after that, like, from there, if you are getting the analysis done, you will get a more accurate value, right? In your home as well, with your home kit, you can do the analysis, you can get your blood sugar levels. But if you go to uh, a chemist or probably a doctor, that using that analysis, the answer will be a bit more correct. Okay, and if you discuss with doctors as well, they might say you that if you are using a digital meter, the value might vary up to 20 units. So if your blood sugar levels are exactly 120, or like probably 200, so it might give you 220 or 180 as well. Okay, this is a 20 unit error that you have. Okay, but you don't want that error. So the minimum the error, the better your model is. So right now the model has 61 unit error. Okay, now, how to get a better model? For that purpose, we have a lot of other models as well. You can go back and try those models. That's not a very difficult part. But this process means this particular class is more of how you can build an end-to-end pipeline, so that you can understand what exactly has to happen. Then after that, you can go to any of the part and tweak these parts. Okay, so not only these basic error after subtracting it, you can also go for the mean squared error, mean average error. You can go for mean square error. You can go for root mean square error. There are different ways to evaluate it. Okay, and here I'm printing these value. We also have R2 score. There are different formulas that we can use to get the errors, but every value should be minimized. The minimum the value is, the better your model is. That's a very basic part. Okay, and after that, here here you can see what I have done. Rather than training the whole model by from the code that I have done, I am importing this particular part. This is loading linear regression algorithm only. Okay. And after that, I'm taking my existing data. I'm taking model is equals to this thing. So this thing will initialize everything. It will initialize the random weights. It will initialize the random bias. It will initialize the learning rate. It will initialize all the in-between parts. It will also initialize how the weights are going to be updated. Everything is pre-built in sklearn so that you don't need to do it by yourself. So once that part is done, so there are a lot of other parameters as well that we have not discussed in detail right now, but right now you can skip that part. But now once I have initialized that model, then we can write model.fit and give x and y, and this is where your model will be trained. That is it. Seriously, that's how easy it is. You don't need to train the model from scratch. You need not to write all the things from scratch. Here I have fitted the model. Here I'm getting the prediction on test data. So this is what my model is predicting on test data. And this is the mean squared error. For mean squared error as well, I'm importing the from sklearn the matrices. I'm importing mean squared error and R2 score. Here I have written the code for finding the mean square error and all these things as well. But here I'm finding it using inbuilt function. So this is what my model is performing. And here you can see here the R square is 0.44 and here the R square was 0.05. Okay. So this is what we have, right? And here mean squared error is 2957 and here it is 5010. So R square value, if I'm talking about, the higher the value, the better your model is. Here, the higher the value, the worse your model is. So that means the model that I have trained now using inbuilt functions, because here I've added some uh, adaptive learning rate and a lot of other iterations as well. Because of that, your model has performed better. Your model has a better accuracy. Okay. And if I'm going for the same model.coef, this is going to print the coefficients of these models as well, which are nothing but these are the final weights of these models. Okay, this is something that we have done in the last class as well. This is the part that we have not discussed, that whatever you have done by writing the code from scratch, you can also do the exact same thing using inbuilt libraries. Okay, so now let's go back to this and let's write the end-to-end process, the step-by-step process, or basically let's discuss about the pipeline of a machine learning project. And then we will see what exactly have we done. And then we'll discuss how the deployment part of the same thing can be done. Okay, because eventually, whenever you have trained this model, what you need to do exactly? You need to just save these weights. That's it. Not only weight the bias as well, but you need to save the parameters. Okay, different models will have different kind of parameters. I'm talking about linear regression, and I'm basically using stochastic gradient descent. Gradient descent is the engine, and you can say linear regression is the car. So inside the car, we can put different kind of engines. Gradient descent is an engine that works best, by far the best. There are different variant of that engine, that gradient descent as well. And that engine is so versatile that in deep learning algorithm and at some level in generative algorithms as well, we are using the same kind of architecture, same gradient descent kind of algorithm. Okay. So now let's do one thing. Let's go back here and let's go for a step-by-step process that what exactly we are going to have. Okay, what exactly need to be there. Okay, so here, if I'm talking about what is going to be the first step, usually in machine learning as well, the first step is starting with agenda. What is the agenda you want to fulfill? If based on the agenda, the steps will go. So once my agenda is defined, okay, my agenda is to make a model that can accurately predict the diabetes of a person. Okay, then what you will do, you will search for like the data sets. Okay, what are the different data sets that are already available in the market that can help you to fulfill that agenda. So because in the agenda, your agenda is to make a machine learning model that can accurately predict the diabetes of a person. And to predict the diabetes of a person, first of all, you need to have the data, right? And to have the data, you also need to have the knowledge that what are the different parameters that impact the diabetes of a person, right? For example, what the person is eating, what's the gender of the person, sex of the person, to be very specific. And on top of that, what is the age of the person, what the ethnicity of the person. So these kind of things actually matters, right? So based on that, you will find the data set. Okay. Once you have the data set, now the next process is pre-process the data set. Because it's not mandatory that whatever columns you have in the data set, all of them are important. There are a lot of columns that are not important, right? There are a couple of columns where I have some missing values. So I need to fill those missing values as well, right? So I need to pre-process the data. And before pre-processing the data, there is another step. Usually you can take both of the step uh, in the exact same way as well. We call it as data exploration. Okay, it's totally up to you. Like if you want to take data exploration and data cleaning in the exact same way or not. So we will explore the data, and whenever after exploring the data, we'll got to know, okay, these are some of the columns that I can remove because they are not very important. Okay, and once that part is done, then we can go for data cleaning. In this particular data set on which we are already working, the good part about that data set is we don't need to do data exploration. All these columns are important. We don't need to go for data cleaning because the data is already cleaned, right? And once that part is done, data cleaning is done, then there's an add-on part here which is called as feature engineering. Now, what is feature engineering? Feature engineering basically means there are some existing columns that are there in your data set. If that sometimes these columns are important, but if we can somehow combine these columns, yes, seriously, we can combine multiple columns together as well and get a new column that is more important, right? For example, if a person is married or not, that's one part. And if a person is male or female. So definitely, like I'm not pretty sure, but if a person is married or not, blood sugar level might depend on that as well. Okay, if the person is male or female, that depends on that as well. So let's rather than having two separate columns, if we can combine both the columns and have one column where you can have a male married, female married, male unmarried, and female unmarried. So I have one single column with four categories, and I will put that column inside my machine learning model. So rather than passing two separate columns, I'll pass one column which has the knowledge of both of them. So these kind of things can be handled using feature engineering. These are the kind of things that are being done using feature engineering. Okay. Now, once this part is done, then now, are we ready to make my machine learning model? Yes, I'm ready to make my machine learning model. And in the machine learning model, usually we'll define models. We'll define ML models. And not only a model, why I'm writing models? Because rather than taking just one model, I'll take multiple models. For example, if this is a classification or regression based problem, this is a regression based problem. So to do this, the best thing you can do is go for all the regression based algorithms, import them. So here we come as defining the model, because you will eventually will not exactly know that which particular algorithm will give you better result, right? You can have a rough understanding, but exactly you will not know until unless you are executing it. Okay. Now, how exactly machine learning models means once we have defined the machine learning models, the next step would be obviously to train my data on the machine learning models, or I would say model training. But to train my model, first of all, the data should be in a format that machine learning algorithms can be applied on it, right? And that is the part we have discussed about this part earlier as well. This is called as data normalization. Will normalize the data. so that all the columns should be standardized in one specific range, right? And after that, we'll define the model, and after that, we will train the model. Okay, once my model is trained, I will evaluate it, and after that, deploy it. Evaluate, and once my model is evaluated, then the final part is to deploy it, right? So you can say like this is too much work, you think, right? And yes, this is too much work as well, right? So this is the whole process. So yes, you guessed it right. There are a lot of steps that are involved in a machine learning project, but those who are a part of the data analysis series that we had done in the last week. So in that week as well, we have made the same kind of process, same kind of pipeline there. Okay, but in that particular pipeline, there are not these many steps. Okay, because in that particular case, we have the agenda, we have the data set exploration, cleaning, feature engineering, but after that we will analyze the data, we will visualize the data. But here in this particular case, we need to normalize the data, define the machine learning models, training the model deployment, and so on. Clear? Now, as per this project that we have worked on, we have the agenda that I know to make a model. We have the data set. Data exploration I don't need to do because the data is already explored and cleaned pretty much neatly. We don't need to do the feature engineering part because that part is already done. Okay. We don't even need to normalize the data because that's also already done. Our task is to define the machine learning models. So rather than defining multiple models, I have defined a very simple one single model. And after that, I have trained my model. Once I have trained the model, I have evaluated the model using RMSE and different scores as well. And I've also plot the cost which should be minimized, and we have plotted it here as well. And through which we can see plot was actually minimizing. The error was actually minimizing, right? So this is something that we have done. And finally, the task is to deploy the model. If your model is not performing great, you can go back, change the model, and see how your model is performing on some other algorithm. Okay. And what are the different algorithms do we have? Go to this list. You can use a ridge regression, lasso regression. These are different type of regressions only. We can use decision tree, random forest. These are a lot of other algorithms as well. Okay. That might give you a better result as well. But to do exactly this, what exactly is happening, what you need to do, whatever code that we have written here, like this is the code to load linear regression. In the exact same way, there will be a code to load decision tree, load random forest. For example, you can take ChatGPT. I'm copying this code just to show you how easy it is. Okay, I'm opening this mode, modify this code to use decision tree as the model. Okay, that's it. And here is the model where it is loading decision tree regressor. Now, decision tree will have their own parameters that need to be passed because, as I've told you, how a machine learning algorithm, specifically linear regression, is trained is a bit different from decision tree. Will be different from KNN. Will be different from k-mean clustering and so on. Okay, but this is what we have. The things are pretty easy. This is what we have. Okay, and this is, if you look closely, here I'm loading the data set, splitting it, defining the model, training the model, predicting and checking the accuracy. That is it. Okay. If not, you can also do this. Okay. Use the list of all the top ML regression based models and train them on my data. That's it. Okay. Now what it is going to do, it is going to take all the popular machine learning algorithms, which are regression based. And now it is loading all of them. Linear regression, ridge, lasso, elastic net as well, decision tree, random forest, gradient boosting, SVR, neighbors, KNN. Okay, it has defined all of them. It has taken the data set into training testing. It is going for a for loop to train on my data set. So earlier, what I was doing, I was taking one model, fit it, predicting it, and checking the accuracy, and then go for the next one. Here, what I'm doing, here I'm doing the exact same thing, but using for loop. I'm taking all the models one by one, fitting it on the data, getting the prediction, printing the error, and saving the result in the result list. So I'm printing the name of the model, what is the R mean squared error, and what is the R2 score. And after that, I'm printing all the data here, and that's it. And here you can see, if you are executing this code, this particular code can give you all the things. So let's do one thing. Let's try to fit it here and see if this code is actually working or not. Okay, no module is tools. Okay, this is something that has not to be used. Okay, df sort values in place true, and let's place results df as well. So here you can see this is what your model is performing. Okay, R square error, and as I've told you, mean square error should be minimized. So let's check which model has the minimum error, and you can use that particular model. That it's that simple, right? So this is exactly what we have. Okay, so if you look closely, here you can see we have machine learning, we have regression, we have linear regression, elastic net, gradient boosting. All of these algorithms are there. Okay, and then you can use whatever model of your choice. Okay, so this is the way how you can go back to this particular step. Exactly this particular step and define different models and train different models and evaluate different models. This is exactly how you can do it. And this is how easy it is. Okay. And once that part is done, let's discuss about the final part where we are going to deploy the models. Okay. Let me take some questions if you guys have any, that I'm pretty sure you guys will have it. Sure. Is it due for optimization only? If you are talking about why I'm doing using different machine learning algorithm, yes, it is for optimization only. We can use any method to calculate. Is there any same way to select the different algorithms? Okay, there are different ways to calculate error in classification and regression based. Okay, usually we just don't have one of them, we have couple of them. So you can take 4 or 5 of them, go side by side and see which model is giving you a better output in most of them. That's something you can check. So to calculate the error, mean squared error to build in function should be done it manually. You need to know how to do it by yourself, and after that you can use inbuilt function. That's totally fine. Okay, we'll be talking about grid cross validation or grid search. No, we are not going to discuss about grid search and cost validation. At the end of the session, if we'll get some time, then we can have a discussion on that, because to reach to the cross validation in that particular part, we need to explore more on data. And uh, the issue with this means, yes, because we have some time constraint here, that we have a 3-day workshop. So going for different algorithms and all the different kind of techniques will not be possible in this particular time frame. But in future, we can have a detailed part, or we can continue the series for a couple of more big, means we can see what exactly can be done to have more detailed discussion on these kind of things. Okay, but right now we'll see if at the end of the session we'll get some time. We can have a discussion on that. Okay, I will get to know about the correct evaluation metrics or different algorithm and problem statement. Is there any thumb rule for recommendation of this matrix or predict in this matrix? Okay, so usually there's no a rule of thumb. Usually we use for classification we have 2 3 matrices, and same goes for regression as well. Like you can see R square. and we use root mean square. Like these are the two main things that we usually have. Okay, and in classification we have what I would say. In classification, we have confusion metrics. We usually check the accuracy directly. And yeah, that's it. These are two, three things we have for classification as well. Okay. But usually to check if your model is performing or not, or if your model has learned something or not, this is something that will tell you if your model is learning or not. Okay. Now let's go to the deployment part. Now, how the model is deployed, how the model has to be deployed. Now, to deploy the model, you need to know one thing. Whenever you are deploying the model, what exactly you are going to deploy? Okay, are you going to deploy the data set, or you are going to deploy the weights, parameters, or basically are you going to deploy the AI model only? What exactly has to be deployed? What do you think? Which part of this whole thing will be deployed? Okay, now you might be thinking that we have the data set. Based on the data set, we have taken the model, right? And we have trained the model. We had evaluated the model, and from the model, we got the best fitted model. So yes, you guys have heard it correctly, or you guys have guessed correctly that we are going to deploy the trained model, the model that we have. Okay. And to deploy the trained model, we need to save the trained model first of all. Okay. And to deploy the trained model, this is a list that you guys can go through after the end of the session as well. There are different kind of deployment you can do. You can go for local deployment. You can go for deployment for web application, for cloud deployment, for containerization, for a very scalable kind of a thing, a serverless deployment where you don't need to take care about the server. You just need to go for the app, and the things, rest of the thing will be eventually calculated. It's a low code kind of thing, or easy to go kind of a thing. On device deployment where you need to uh, run your models on mobile applications, on mobile phone, offline interfaces, right? And batch processing and hybrid deployment as well, where you need to run your model on Raspberry Pi and Arduino and these kind of things. Okay, so there are different kind of deployment, and there are different kind of tools used for each kind of things. Okay, so there's something that I will add in the notebook only, so you guys can check that out at the end. But eventually, my task is to deploy the model. Okay, so to deploy the model, first of all, I need to save the model. Okay, and to save the model, I have done one simple thing here. I'm going to share with you a notebook. Okay, so here, if you go to my GitHub, and in GitHub repositories, here I have added two things. Okay, so there is diabetic prediction, the first one, and diabetic prediction Gradio. This is something that is just that is deployed on Gradio, and there's something that is deployed on Streamlit. Both of them are Python framework that will help you deploy the models on the cloud. Okay, what I'm doing, both of them will have the common point. Okay, and if I show you what exactly do we have, it's easily something you can see. So here we have train model.py. If you open it here, you can see what exactly I'm doing. I'm loading the diabetes dataset. I'm splitting it in train and test. I'm fitting in linear regression, fit the model. And once my model is trained, I'm saving that model as model.pkl. This is a way how a model can be stored. A machine learning model can be stored. There are a lot of other ways as well. And I'm using joblib library for that. So that's why joblib is imported. So this particular Python code, if I'm executing, it will create a model.pkl file, which is a trained model. That is it. That's a very basic code. Okay. And what is this model.pkl? This is the trained model file. Okay. Now, what do we have in requirements? In requirements, I have added all these requirement libraries that are being required, because whenever you are writing the codes in, because so far we have written the code in uh, Colab. But usually whenever you are going to deploy an application, the deployment you are not going to use collab. For deployment you are going to use VS Code, right? So in VS Code you need to create an environment, and once the requirement is created, uh, environment is created, you will add the requirement, like these are the libraries that will be needing. Like in this particular case, Streamlit is mentioned, but Streamlit is, I think, yes, Streamlit is needed here. And now you know like about these three things. This is the train model, this is the library, that this is the code that will help you train that model, and these are the requirement files. Because whenever you are deploying this model, the model inside that model, you are going to deploy all these codes. Even if you are skipping this particular part, that's totally fine, because this is to train this model. And if the model is already there, what is the use of training it? So you can remove this part as well, and still the model is deployable. But to run this model, to get the predictions, you need to define what are all libraries it is going to use. These libraries will be installed on their server, whichsoever platform you are using. And in this app.py, you have the exact code that will basically generate a website for you. So if you go here you can see I'm using a Streamlit library. So on Streamlit, I'm using so Streamlit is something that will also help you make the web interface. It will also help you write the code. HTML, CSS kind of the web interface, or it will basically ask you write the UI part. Okay, if you go here, st.title, this is the title. This is going to be the title of the UI. Okay, it is going to load the model. And once the model is loaded, it's also adding the subheader, and it's adding a text input with the default text that's already written. Okay, I'll explain you what exactly is happening. And whenever someone is going to press a button, the name of the button will have the prediction, the progression. It is going to take the input, reshape it into features, and get the predictions. Model.predict. And whatever prediction you will get, you will do the predictions, and otherwise print invalid input. Now, this is my app.py. This is something that is going to be executed. Okay, so if you go back on my Streamlit, this is how the deployed app looks. And if you go back, this is exactly what we have here. st.title, this is the title. This subtitle, this is the text, this is the text bar, and this is the button that I was talking about. If I'm pressing this button, input, why I'm getting this particular output? Because I mentioned here invalid input. And if it is a valid input, for example, now here, what is going to be the valid input? This list is going to be a valid input. Now you might be thinking, sir, how this list is going to be a valid input? Because we have trained this model to predict the diabetes of a person based on 10 different values. And this is how these 10 different values are, right? Rather than having these 10 different values added directly in a list, you can also create 10 different text bars. One is to add 6, another one to X, to add your BP, another one to end the S1, S2, whatever columns that we have, right? So rather than having just one bar, you can also have 10 separate bars. But here, just to make the things easier for you, so that you can see, you can basically deploy an application with minimal efforts. This is what you have. Okay, and here you can see the diabetes of the person should be around 210. Right. Now the question is how you can deploy it by your own. For that purpose, you need to, you can take the same code as well. You can take this particular repository. You can go to code, you can download the zip file. Okay. And once you have downloaded, you can create a new repository by yourself. And once you have created the new repository, paste all the files here. Once all the files are pasted, you need to go to Streamlit. Okay, this is the streamlit.io, which I'm talking about. And you can register yourself, try for a free one. And once you have it, you can go for different kind of things that you can talk, that you want to. Like this, the one that I've already made. Okay, what you can do, you want to create a new app. So click on create app. And at this time, I'm going to deploy the app from GitHub. So click on GitHub. And here you need to mention the link of your GitHub repository from where you are going to fetch it. So where exactly is the GitHub repository? That's the GitHub repository I'm talking about. So let's add it here. Okay, if you're doing it for the first time, it will also ask you to authenticate your GitHub ID. So you need to log in with your GitHub as well. So it will automatically fetch like what are all the GitHub IDs do you have? Like what are the different GitHub repositories that you have made? So inside that, here you can see the branch is main. And inside it, here you can see it is automatically detecting which py file you are going to run. Now you guys tell me which py file is something I need to use. If you go here, there are two py files here, app.py and train model.py. Which one I should be selecting? App.py. Why app.py? Because app.py is something that will make the web interface that has the code to run the web app, right? So go for app.py. This is going to be the final link of this. Okay, that's fine. So click on deploy and wait for it to deploy. That is it. Seriously, that is it. And here your application is deployed. You need to go for this, predict progression. This is what you have got. Okay. If you need to modify the code a little bit, for example, this is the app.py from where it is fetching all the things. So this is what you have. You can also copy it. Okay. I'm doing something different this time. Okay. And this time I'm going for this. I'm writing modify this code to have 10 different columns in text field. But I also need to mention what are or what are these text fields. So I am also mentioning the name of the column. These are going to be the text fields. Okay. And then a final button to get predictions. Okay. So now I'm expecting it to modify the code of Streamlit only to run the app. So here you can see it has added a text input X, age, sex, BMI, and all these things. And whenever the button is pressed, all these values will be taken into a list because this is how my model will take the input, right? So now I think I can make it work. So for that purpose, I'm going here. I'm just editing this particular part of the code. Commit the changes. And the changes are done. Let's go back. And this is the changes that I need to do on my main app. Okay. So here you can see it is done in real time. It is done in real time. I don't need to change anything. Now I have age. Now in this particular case, I need to add all these things separately. I need to add age separately and I cannot pass the exact age 24 and sex male and something like that. I need to add them in terms of the same way as we have trained the model. Okay. So now you might be thinking, sir, exactly there should be a age like 25, right? So what we need to do in that particular case, you need to build a pipeline for this as well, such that this app.py will take all the inputs. Once you have taken all the inputs, all the feature engineering that we have done using transformation and everything, you need to do all the same transformation here as well. Once that transformation is done and all the text and categories are converted into numbers, then combine them, then give to your model and get the predictions. And here you can see, just to see, predictor by Ashish, just commit the changes. And I think the commit is done. So now let's go back. Here you can see by Ashish is also written. That's amazing, right? And this is the web app link. You can share this link to anyone and it will work. Right. So that's how easy it is to deploy your machine learning algorithms, to deploy your machine learning models. There are some drawbacks of using this because you can only deploy the model till 100 MB size on Streamlit. And Streamlit is something you will usually use when you uh, use when you want to use it for prototyping purpose. Okay, they are not used, means Streamlit is not used for full-fledged deployment. That is used for testing. Okay, or some dummy apps, some web apps, right? But if you want to go for a full-fledged application for that purpose, you should not use this one. You should go for some high-end paid or basically premium kind of a model that you can see here that you can use for deployment. Okay, the way you have used Streamlit, the exact same way you can also use Flask. Okay, and in the exact same way you can also use Gradio. And here you can see in Gradio as well, I have deployed the same app. Okay, where I'm giving the text field, click on submit, and this is the output that I've got. And that's the space that I have. So I can share this link with you and you guys can try it out as well. Okay, not only that, this time, here the model is deployed on Streamlit. Here the model is deployed on Hugging Face spaces. How many of you guys have used Hugging Face? Yes, you need to use standard scalar, Subi. That's correct. You need to, if you want to take all the columns separately, then you need to use standard scalar to standardize all the thing, and then go ahead with it. Ashar has used it. Okay, that's great. So if you have not used it, this is a great place to be. Hugging Face uh, is a new Kaggle. Okay, and it has a lot more functionality as compared to Kaggle as well. Okay, because if you go to datasets, it has a lot of datasets, like 4 lakh datasets directly available here. Okay, and these are high-end datasets. If you go to models, we can also get high-end models here as well, right? You can get Mixtron AI, you can get Gemini, you can get Google Gamma 4b, you can get Llama, and you can also go for any of these things. For example, if you want to make a model for if you want to go for a state-of-the-art model for image classification, click here. These are some of the state-of-the-art image classification model, and this particular model, if I'm talking about, is downloaded 101 million times, right? Is it 101 million times? Because I'm also pretty confused. 101 millions is a big number, and that is correct. And these are the number of downloads in just last month. Okay, and this is for image detection. Okay, that's the model that you have, and you can also use this model for inference here as well, that you can drag and drop an image and see what kind of output this model will give you. Okay, so this is a pretty huge uh, thing that we have, pretty advanced thing that we have, Hugging Face. Okay, and in Hugging Face as well, you have the option of spaces. You can go to spaces and you can deploy your model here. I've used it for deploying a very basic machine learning models, but people are using it to deploying deep learning, computer vision, generative AI models as well. Seriously, you can use these models here as well. Okay, and these are some of the templates, some of the spaces that people has already created. Okay, and yes, you can create your own space as well, as I have created my own space. This is for new space, but I have already created my own space as well. And inside that space, I was deploying my Gradio app. Okay, and how to do that? That's also pretty simple. Go to spaces, go to create a new space, and once a new space is created, define the name of it, define Gradio here. And once you have defined the Gradio, rest of the things are pretty much simple and straightforward. But whenever you are creating a new space, okay, for example, this is the space that I have added. The code that you have written here means the code that I have written here, rather than giving the code here, you need to install VS Code. On VS Code, you need to write all these codes, and using Git commands, you need to push the code on that server. Okay, so rather than directly dragging and dropping it, giving them the access to it so that it will not run that way. You need to install VS Code. Inside that, you need to pass all these codes, and through VS Code, you need to run it. So that's why I have used this repository. And here, because in Streamlit, I need Streamlit. Here I have the same thing, same model, but here in the requirement, I have added Gradio instead of Streamlit because Streamlit is not something I'm using now. I want to deploy it on Gradio. So this is the app format of Gradio. And here you can see rather than going for Streamlit, I'm using Gradio. And here, this is the code to go for this particular interface that I showed you earlier. And this is something that will launch the application, and there's the text format, and this is how you will get the output. Okay. So we have discussed about two ways to deploy the application. We can also you can do it in either Streamlit or Gradio. These are both good platforms to start with, so that you can have the gist of how a model can be deployed. Okay, and once it is deployed, it is good to go, right? So now, if I go back to SQL Draw, so this is the step-by-step process that we have. Okay, and these are the links that I've already given to you. And this is the app link. This app link will not be that useful. This app will be, because here you need to pass all the data in just one go. So I'm sharing this link with you guys. Okay, that's the existing one that I've changed. Okay, that's totally fine. But this is something that I have made. The exact same kind of thing you can also make. Rather than going for a very basic algorithm, you can go for an end-to-end one where you're doing the feature engineering, doing the machine learning part. Rather than going for a basic ML, go for a larger data set, deep learning, generative AI kind of application as well. That's also something that can be easily executed on Streamlit. Okay, I've seen people making chat GPT kind of things, chat GPT kind of an interface or kind of a chatbot on Gradio, on Streamlit. Okay, so that is something that you guys must check it out. Clear? And not only that, there's one important thing that I've missed. Okay, and that is make sure to start using chat GPT or Gemini specifically. Like I was using this Gemini interface day before yesterday, and here I have made something. Okay, and this is nothing but a visual representation of how support vector machine works. SVM is the algorithm that I was talking about, is there in the graph as well. So basically, whenever you have the data, imagine if you have like two inputs and two outputs. Sorry, two inputs and one output. So two input is something you can plot in XY, and all the points at the right are from category 1 and blue are from category 2. So SVM will help you to draw a line that can easily distinguish between category A and B, right? And go for random cluster, it will draw the line accordingly. Not only that, you can select any of the dot by yourself as well, and the line will change. Clear it. If you want to draw, like, these are some of the points for class A and these are some of the one for class B, and here you can see the line will change itself. Okay, this is the interactive and I have made it using just giving text prompts, like make a user interface where you can play with it. Not just this, I have also made the same thing with 3D representation of it, right? This is not this was support vector machine, but this, if I'm talking about, this is an application of KNN. So imagine, rather than having two categories, I have three categories, and now uh, I have this thing in 3D. So you can either make any point of your choice, and that too of any category of your choice, and you can select any cell as well. So here you can see, once this particular cell is selected, it is finding the 7 nearest point to this, 9 nearer point to this, which are at this particular axis. Now, even if you are not understanding exactly what is happening in here, this is just to show you that to understand any basic machine learning or deep learning algorithms, now you have tools like Gemini that can give you 3D representation where you can play with these models and check how each model is changing, right? Like this one is something that I made for deep learning. Okay, where you can add new layer, where you can remove the existing layer, where you can change the number of neurons in this particular layer, and let's go for 5. And this is how this neural network looks, where you have 4 inputs, three outputs. Okay, let's modify this part as well, so that rather than going for three of them, let's go for, and then not only that, you can go for any of this neuron and check the connection of that as well. Okay, and this whole application, seriously, this whole application is something that I have made. If you go to the code is written in React. Okay, and I have never used React in my life. I've never used React. This is something that it has made by just me giving prompts. Like, this is what I want. Okay, the better prompt you are going to give, the better it will become. For example, this time if I want, like, what is this extra area that you are occupying, remove this particular part, it will remove it. Okay, and this is a fascinating part. You can go for any of these connections as well. Now this is more of a deep learning part, but you can click on any connection, it will tell you what this connection is telling you. And you can click on any cell, and here you can see this value will depend upon all these connections here and all these numbers here. This is a visual representation of neural networks. And believe me, the time when we were learning it, right, we were not having these kind of beautiful representation where we can exactly simulate like what exactly, how exactly a neural network looks. Okay, but now with just 15 to 20 minutes of prompting, you can come up with something like this. I come up with something like this, which is another algorithm, KNN. This is SVM. This is neural networks. And same kind of thing, I'm also trying to plan for RNN, convolutional neural networks. We can definitely have a detailed discussion on each of the machine learning algorithm, each of the deep learning architecture. And I'm planning to go for the same kind of things, and we'll try to do it with these kind of simulations where you can exactly see what's happening in each of the algorithm. Okay, rather than just doing the maths of it, it would be great if you can dig deeper into each and everything and simulate how these connections are made, how the parameters are calculated in this particular case, right? So that is it. If you guys have any question, do let me know. Okay, sir, once more explain the SVM part. Okay, so SVM is nothing but support vector machine. Okay, it is an algorithm that will help you uh, draw a best fit line. For example, if I'm talking about linear regression will draw a best fit line on the data, right? Logistic regression will also do the exact same thing. But sorry, SVM will also do the exact same thing. But this time, this line is used for a classification, because for classifying means whenever some random points do we have at the left, we have like points which are from class A, at the right we have from class B. This algorithm will draw a best line that can separate these data sets. Okay, and here you can see, irrespective of how the data set is distributed, it will automatically find a best fit line that can separate both the data sets. Okay, and on right of the data set, and whenever a new point is coming in, we can check if that point is at the left of the line or not. If at the left of the line, the point should be of red category, otherwise should be of blue category. This is a classification based algorithm. Okay, and like, this is just to display you that this is in 2D, but you can also have in 3D, 4D, 5D as well. The algorithm will also work in that particular case. Okay, and these are some different algorithms. Like, this is k nearest neighbor, where you can click on any of the unknown point. For example, this one, if there is a new point, I don't know what this category belongs to, click on this, and here mention find 5 closest point to it. And these are the 5 closest point. Out of 5, 3 of them are from category C, 2 of them are from B. So the product should be from category C, because there are more of C's, right? And if I'm going to this blue region, so definitely if it's in blue region, most of them should be category C. So the most popular one is category C. This is also a way of doing it. Okay, this is a visual representation of how it is being done. Okay, and so far I'm using 2.5 Flash. We also have 2.5 Pro models, which are a lot better than 2.5 base model. Okay, which is just released probably a couple of days ago only. 2-3 days ago only this model is being released. Okay, not visible on website until it was live. Okay, I don't know why it is not visible. Probably you need to go to live section. I checked earlier, it was visible. So this is the end of this 3-day series on machine learning. So in future, if you want like more such discussion on any of the specific topics, do let me know in the feedbacks. Do let me know in the chats. Do let me know in the Facebook comments or wheresoever you are watching it. So we'll plan to have more such session like this. Okay, the type of prompts you have given, yeah, these are very basic prompts. Like I started with a very basic prompt, like for example, if I'm talking about this one. Okay, I started with a prompt, make a canvas app where I can pass the number of layers, neurons, and number of features, and sorry for the spelling mistake, labels and neural network will be visually created in dark mode, minimalistic way, in all the stable connection, make professional one in the same proper UI and UX. And after that, I'll just, it has given me this particular code. And after that, I've given at this particular functionality, remove this, add this, remove this. And after going for multiple iterations, this is where I reached. Okay. If you want to go, don't want to go for Gemini, that's totally fine. You can go for Firebase Studio. Firebase Studio will make the things a lot easier for you. It will not only help you to make this, it will also help you to deploy this as well and get a final link. That's it. That's how easy it is. On YouTube, you can get a video about that as well. Let me share that with you. Like we have published it probably a week ago, week or 2 weeks ago, I think. And the video is mm, 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 this one. This one is of Firebase Studio. So in this video, we have discussed about the different aspects of how machine learning or how easy it is to make the models. And here you can see I've made a game of tic-tac-toe. And the game is something that I made while I was in the video, right? So here I've given a prompt, and this is on Firebase Studio. And once given the prompt, it is setting it up and is creating all these files for you. And this is the file that it has made. And after that, I'm changing the prompt at the right here. You can see I'm just adding different kind of prompts. And this is the game that I've got at the end. This 24-minute video. And in the video as well, it took me around 15 minutes to build it. Imagine without a video, if you are doing it by yourself, how much time it's going to take. Hardly 10 minutes. And I have added a lot of rubbish prompts as well, just to show you the functionality that what exactly it can do. Okay. And once this part is done, this is the final tic-tac-toe app. Okay. I need to check if it's still live or not. But yes, and it is live. You can play tic-tac-toe with it. And here's the next game. And it is keep tracking of the progress as well. Why I have added two of them? Because I just want to check if it can do it or not. That's it. Right. There's no reason I have added two of them, because that does not make any sense, first of all. But I have added it just for the sake of seeing like if it can work or not. Okay. So that is it. And let me share this particular part with you, which is going to be important. And for this one as well, this is also going to be important for you. So either you, if you want to go for Gradio or diabetic prediction directly, I'm copying this and pasting it here so that you guys can check it out after a couple of minutes as well. So copy link address. Yes, that's the one. So this is for diabetic prediction, and this is the code for do the exact same thing with Gradio. So that's totally up to you which one you want to use. Okay, for Firebase, for sorry, not for Firebase, but for Streamlit, The first one is something you can use. Second one is something you should be using if you want to go for Gradio. Okay, go for GitHub, upload it, clone it, upload it, and after that you can easily access it. Okay. So if you guys have any question, do let me know. Otherwise, like we can wrap up this session. Okay. So this is the 3-day workshop that we have done. Eventually, let me share this final link with you so that you can easily use it. Copy and paste it here. And this is the GitHub repo from where you can get the code that we have written yesterday. Okay. How can get that 24-minute video? Okay, it's there on YouTube. Okay, which is the name Firebase Studio is here. I'm pasting that link here as well, so you guys can go and check that out. There's another video that I think is really important for some of you guys, which is this one. How you can use these LLM tools, AI tools, and how what exactly they can do. Okay, and what are the categories or job sectors which are going to be which will be impacted because of this, and how you can basically make your job role a kind of not exactly like future proof, but yes, it is more toward the direction that your job will be safer. Okay, so make sure to go for this one as well. It will give you a bit more understanding. Okay, this is in Hindi, so those who don't know Hindi, like they can check if there is a different language or not. That would be otherwise difficult. Or you can use any plugin like this, copy paste it, give it to ChatGPT and ask it to give you a, a sweet 2 to 4 minute summary. Okay, so start using these LM tools, these AI tools. They are going to be really helpful for you guys. Okay, so that is it. Thank you so much everyone for joining in. I've tried to deploy Streamlit, but it's giving not found error. I'm not sure if it is wrong or not. Okay, so doing in Streamlit is something that I've showed you. Okay, it's that simple. You need to just clone your repository on your case, go to Streamlit, create an app, give your authentication, and through that you can automatically check this. It will automatically detect these are all the GitHub repository that you have. This is the app file which you want to use. Just click OK and it will start fetching the data for you. Okay. And as I've told you, if you want more such session, give me the feedbacks probably on YouTube or chats and comments. We'll be having more such sessions in generative AI, in LangChain, in Hugging Face. We can have it. Thank you so much, everyone, for joining in, and I'll see you in some other session. Take care, everyone. Bye.